Alright, so good day everyone. So let's go back with my YouTube channel. And today we will be talking about using a probability density function to find the probabilities of continuous random variable. So this is Kasaligan Vlogs. So if x is a continuous random variable, then the probability of it falling between x is equal to a and x is equal to b is given by the area bounded by probability density function. The x-axis at the lines x is equal to a and x is equal to b. This area can be easily calculated by evaluating the definite integral between a and b. So this one, and this is the illustration. So if the intervals involving infinity, in many instances, we need to integrate over intervals involving infinity. In such cases, the limits are evaluated shown in the right, here one. When evaluating the involving infinity, it is useful to remember that a number tends to infinity, its reciprocal tends to 0. So take note of your calculus class. So for example, the limit of 1 over x as x approaches infinity is equal to 0, and limit of 1 over e raised to x as x approaches infinity is equal to 0. This concept is illustrated in this example. The interval from negative infinity to infinity and so on of this. So we have to take note of this interval and its limit. And also we have to take note of our probability or calculus class about the limit of infinity. So let's try the first one. So if the continuous random variable with the probability density function is defined, so 1/2 x minus 4, the interval is x greater than or equal to 8 but lesser than or equal to 10, and without this interval, not ranging this interval, 0 elsewhere. So find the probability is greater than 9. So what we're going to do here is we need to find the probability greater than 9. So PR x is greater than 9 is equal to, so starting with 9, so therefore we have the integral of from 9 to 10. So greater than 9, but we need to start with 9 to 10. There's 1/2 x minus 4 dx. So equal to, we are going to integrate this one. So we have here, this is x squared over 4 minus 4x from 9 to 10. So we have here 10 squared over 4 minus 4 times 10, then minus 9 squared over 4 minus 4 times 9. So this one, we have 10 squared divided by 4 200, that's 25. 25 minus, this is 10, 40. Then minus 81. 81 divided 4. That is 20.25 minus 18. Ano, wait, 36. That is negative 15.75. So negative 15. So this one is negative 15 minus negative 15.75 we have this becomes 0.75. So the probability greater than is equal to 0.75. Okay. So next we have here probability x is greater than 8.5 but lesser than 9. Okay, if we're going to illustrate this one, by the way, so the illustration of this one is that, okay, when x is equal to 8, the result is when x is equal to 8, the result is equal to 0. When substitute, that is 8, 0, and when 10, that is equal to 1. Wait, wait. 5 minus 1, the 5 minus 4 is 1, so we have 10 and 1. So I mean this is 10 here and this is 1. 10, 1. Illustrate this one. So from here we have 9 and from here we have 10. So the probability that we need to get is only from greater than 10. So there's greater than 10. So that's a probability that we need only to get. Next we have here letter B. So B, so that is equal to the probability x is lesser than 9. So by the use of this integration, x squared over 4 minus 4x from 8.5 to 9. So we have here is equal to integral of 8.5 to 9. They have 1 half x minus 4 dx. So starting here from this will become x squared over 4 minus 4x 8.5 to 9. So substituting the value we have here 9 squared over 4 minus 4 times 9, then minus 8.5 squared over 4 minus 4 times 8.5. Okay, 9 squared, 9 squared divided by 4, that is 20.25 minus 36 minus 8.5 squared divided by 4, that is 18.0625 minus 4 times 8.5 minus 34 is equal to negative 15.75 minus this is negative 15.9375. So the probability is equal to 0.1875. So if we're going to illustrate this one, so the illustration would look like this. So using this illustration, this one, this is 80 and this is 10, 1 here. We're going to connect like this. Okay. from 8.5 from 8.5 to 9. So we have to get from 8.5 to 9. So the probability is 0.1875. Next we have here letter C, that the probability of x greater than 9 given that x is 8 point greater than 8.5. So this is conditional probability. Conditional. So in conditional probability for letter C, probability of uh, x is greater than 9, x such that x is greater than 8.5. So it could be written that when x is greater than 9 and x is greater than 8.5, the probability formalized that probability of A such that given that B had happened is equal to probability of A and B over probability of B. Okay? So this case, so we could write this one as probability. What is the intersection of probability of greater than 9 to 8.5? So if we're going to have the intersection here, like here, 8.5 and isa is going to 9 here. So the intersection, this is 8.5 and isa is 8.5. So the intersection is going to x is greater than 9. So therefore, probability of x is greater than 9, we could simplify here. And next is that because we have here probability of x is greater than 9, intersection of probability of x is greater than 8.5. This is how to write. Then probability of 8 x is greater than 8.5. So we could write this one as when we're going to get the intersection of this one. So therefore, we could have only for probability of x is greater than 9 over what is all the probabilities from x is greater than 8.5. So this one, probability of 8.5 and between 9 and 8.5. So we could write this one as probability of 8.5 to 9 plus the probability of x is greater than 9. We are going to add the probabilities. So what is the probability of x is greater than 9? So the probability of x is greater than 9 is 0.75. Okay. And all the probability going up until 9 is equal to 0.1875 plus 0.75 is equal to 0.75 over 0.9375. If we're going to simplify that one, this is 0.8. So this is conditional probability. Okay, let's proceed with the next part. A random variable x has its frequency curve as the function 1 half e raised to negative 1 half x, x is greater than 0 or 0 elsewhere. Okay, so first let's draw the graph of a function f of x. So therefore, this is the illustration. This is the answer for letter E. I just draw this one so that it could be accurately shown here. So if we're going to substitute the value for our x is equal to 0, when you substitute in the function, the result is 1 half. Okay. Okay. Shift E. Okay, this is an Euler. alpha e raised to, okay, from 0 then to 1 half. But it's open interval here, and uh, it's decreasing function starting from point zero 0.01 half, and horizontal asymptote to y is equal to 0. And show that the function is a probability density function. So if we're going to show that the probability is a density function, it should meet the requirement. But since that is greater than 0, from 0 to the infinity, we're going to recall this principle. Okay? We're going to recall this principle, intervals involving infinity. So the first thing that we're going to have is that when f of x is greater than 0 for all x, so yes, they say since if we're going to graph this one, this is asymptotic. So for example, when L raised to greater than 0, that's equal to 1, that's all, that is 2.7, ganyan. Okay. When e raised to 0, when a raised to 0, that is equal to 1, so therefore times 1 half here, that is equal to 1 half. Going down here, if we're going to illustrate this is asymptotic to y is equal to 0. So therefore, f of x is greater than 0. Check, because this is just asymptotic to approaches to y is equal to 0. The next condition is that we need to find whether this one, the area is under the curve is 1. So to make it a PDF. So the area is equal to the limit of from 0 to k, or from 0 to x, where k is approaches to infinity. There's 1 half e raised to negative 1 half x dx. If we're going to take the interval of this one limit as k approaches to infinity, from 0 to k, from 0 to k, 1 half e raised to negative, I'll just write it back. So we have a limit as k approaches to infinity. So by the use of our calculus, so therefore this is 1 half e raised to negative 1 half x. This will become e raised to u plus c if we're going to integrate this one. Okay, so what is e raised to u? Then times our u here is negative 1 half x. Our du is equal to negative 1 half dx. So therefore, our neutralizing factor is negative 2. We need to have a neutralizing factor. So we will just put 1 half here, 1 half, then the neutralizing factor of negative 2 by calculus, e raised to negative 1 half x, and from the limit from 0 to k. Okay, equals, cancel this one. This is limit as k approaches to infinity, that is negative e raised to negative 1 half x, 0 to k. Okay, so if we're going to substitute this one, limit as x approaches to infinity, that's negative e raised to negative 1 half x, 1 half k, minus e raised to negative 1 half times 0. This is still negative. Okay. So this is negative e raised to negative 1 half k. If we're going to proceed this one, so this is the limit. So we can have k rather approaches to infinity, that is equal to negative 1 over e raised to negative 1 half k minus negative 1 over e raised to 0. So this 1 negative 1 over e raised to negative 1 half k as x approaches to infinity, if we're going to take the limit of this one, that is equal to 0. 0 plus, because of this principle, okay, that is x approaches to this one, okay, that is 0 as x approaches, so infinity, and this one will become negative 1, this is negative 1, and this is equal to x raised to 0, that is equal to 1, so therefore plus 1. So the area is equal to 1. So therefore, this function is a probability density function. Okay, let's proceed now with the next example. If x is continuous random variable with the probability density function given, the function 4 minus 2x, the interval is x is greater than or equal to 1 and x is lesser than or equal to 2 and 0 elsewhere within that interval, find the value of a such that the probability is lesser than or equal to a is equal to 0.75, where the interval is 1, a is greater than or equal to 1 but lesser than or equal to 2. So first is we need to have PR x is greater than or equal to a, that is 0.75. So this is the function. So therefore, since lesser than or equal to a, so starting with this interval, so we have here integral of lesser than or equal to a. So therefore, a here, this is our a, this is the limit, lesser than here until 1. Then 4 minus 2x as a function, dx is equal to 0.75. Then we need to integrate this one. So the result of this one is 4x minus x squared over 2x squared over 2. Okay. From 1 to a is equal to 0.75. So cancel. This will become 4x minus x squared from 1 to a is equal to 0.75. Substitute the value for a here. So for a minus a squared, then minus 4 times 1 minus 1 squared is equal to 0.75. So 4a minus a squared minus 4 minus 1, that is equal to 3 is equal to 0.75. So a squared minus 4a plus 3.75 is equal to 0. If we're going to factor this one using your calculator, the result would be A is equal to 5 halves or A is equal to 3 halves. So factor this one. The result is A is equal to 5 halves or A is equal to 3 halves. Since the interval is 1, x is greater than or equal to 1 and x is lesser than or equal to 2, so our value of A is 3 halves, not included this one because 5 over 2 that is greater than 2. So therefore, A is the value for A is equal to 3 halves as part of the interval. So try this at home and complete or solve this one. And thank you so much for listening.